Hi, grade 7. This is a math video for 198, 199, and 200. It is a study guide and review. We're going to do numbers 1 through 8 together, so that's going to shorten up your assignment a little bit. And I'd like to show you some of types of problems that you're going to be facing in each section. So let's start with 9, 10, and 11 on 198, 9, 10, and 11. I'm going to do one similar to number 9. What if instead of what it says, number 9 looked like this? 7 students compared to, say, for example, 49 students. What would they want you to write? Well, the directions say to turn it into a ratio in simplest form. So I would just write it as a fraction and simplify it down by dividing the top and the bottom numbers by 7. Look at number 11. That one's a little bit different. It's got a comparison of inches to feet, inches to feet. I'm going to do one similar to that. I'm going to do 4 inches compared to 4 feet. Well, at first glance, maybe you think, I'll just do this and simplify it down to 1 over 1. But that's not what they want you to do here. Inches and feet are two different labels. I'm going to have to change either the inches into feet or the feet into inches. And I think it's easier to change the feet into inches. There's 12 inches in every foot, so 4 times 12 would make 48 inches compared to those 4 inches. This doesn't look like the same fraction as that, but these two fractions are equal to each other because 4 feet is 48 inches. Now this we can simplify down to 1 over 12 because both of those numbers are divisible by 4. Let's go to number 12 at the bottom. They're looking for rate of change. Rate of change. And in this case, it's between ages 12 and 15. I'm not going to do that one, but I'm going to show you one similar. What if I had a table with x and y, and somewhere near the end you had 12 and 15, like yours does, but instead of $3 and $5, what if instead said, say, $4 and, say, $9? What would I do with that to find rate of change? Well, if you look back at the formulas that we talked about for lesson 4-2, this all revolves around this formula. Does that look familiar? No, it's kind of like the slope formula. Which one's the second y? The second y is the $9, and the first y is the $4. The second x is the 15, and the first x is the 12. So we would get, what, 5 over 3? But these are supposed to be rates of change, and so the rate of change here needs to be changed to a number that has 1 as its denominator. So 5 times 1 divided by 3, what does that give us? It gives us approximately 1.6 repeating. Now what's the labels on this? Well, we are comparing dollars on the top and ages on the bottom here. So because y is money value in this problem, and x is age in years, right? But we're flipping everything because we're doing the y's on the top. So this is really more like $1.67 over the top of 1 year. Huh? Where did I get that from? $1.67 over 1 year. Well, this is money, so it needs to have 2 decimal places, right? Compared to an amount of years. Money on the bottom, years on the top, right? So in this particular case, we're talking about the weekly allowance differences from 12 to 15, and we're getting a weekly allowance difference of $1.67 per 1 year. Okay, top of the next page. They're looking for slopes there. They're looking for slopes. Be careful. Remember that sometimes slopes are positive and sometimes they're negative. Do you remember how we figure out slopes? If I had a graph that looked like this, and it had dots here, and here, and here, and And let's say I put a dot right here, and I put another dot right there. And then I put a line through them. First of all, would that line have a positive or negative slope? Remember, start in the left side, work to the right side. Do I have to go up or down to get to that next dot? I have to go up. That's a positive rise. In this case, how much am I rising? I'm rising from 1 to 2. That's a rise of 1. How much am I running to get from here over to here? I'm running 1, 2. This is a slope of 1/2 in this particular case. Because I'm rising 1 and I'm running 2, and it's a positive 1 because I'm going up as I move from the left to the right. But what if I switch it a little bit? What if I make my line look more like this? I put a dot here, say, and how about a dot right here? And I want to talk about rise over run now. Well, think about it. As I move from the left dot to the right dot, from here to here, am I rising or falling? I'm falling. By how much? By 1, 2, 3. So that's a rise of a -3. And then how much am I running to get from here over to here? From here over to here, I'm running 1. So my slope is a -3 slope in this particular case. Can I do that with a table, like number 15? You bet I can. Table Schmeeble, right? If I have x and I have y, and I have these values of x, how about 2, 4, and 6? And I have these values of y, how about 10, 8, and how about 6 again? 10, 8, and 6. All I got to do is pick any of the 2 ordered pairs and use that formula, second y, how about 8 minus the first y, over the second x, 4 minus the first x, and I get -2 over 2, or a slope of -1. Oh, how about 16 to 20? 16 to 20, do you remember how to solve a proportion? I hope you do. It's just simply cross multiply and divide by the remaining number, right? So if I had 3/7 equaling, how about x over 21? I could take the 3 times the 21 and divide by 7. In this case, x would equal 9, right? What if I wrote a problem like number 20? A turtle can move 5 inches in 4 minutes. That seems awfully slow for a turtle. What if I said 5 inches in 2 minutes and made it twice as fast? And then somebody says, let's see, how far will it travel in 10 minutes? Well, what if I said, how far will it travel in 20 minutes? Twice the length of time. Well, if it were me, I'd set up a proportion where I'm comparing the minutes to the inches. And when I write in the 20, that has to be on the bottom, because I'm going inches over minutes, so therefore inches over minutes. And in this case, x would end up being 50 inches of travel for that speed demon of a turtle. Okay, 21 to 23, that's using proportions to solve similar polygons. Don't forget to draw a picture for 23. Oh, backside. Oh, why don't you ask me if you have any questions about that? I think I'm going to stop at this point. Thank you. Have a good day.